Hello, welcome to Build 2017. We're going to talk about Cortana Advanced Language and Voice Design Skills. I'm Shane Landry. I'm a designer that works on Cortana and voice design across Microsoft. Oh.
The mic on?
Okay. Well, this is Sami.
Okay, I think I'm on now, right?
Oh, yeah,
My name is Hisami Suzuki. Shane is going to talk about the designing the skills. I'm going to specifically talk about language understanding portion of the talk. I have been working on language understanding for the native skills of Cortana since the beginning. So I would like to share some of the experiences that I have in this journey.
Yeah, hi, and I'm Andy Wigley. I'm a senior software development engineer in our developer experience group. I've been working very closely with Cortana Skills, getting our partners, our early adopters, to build the first Cortana Skills, and working with engineering. So my role in this talk is to turn all the great stuff that these guys are going to explain to you into a practical example of a Cortana Skills which uses a lot of the techniques they'll be talking about.
So we're going to start with a little call to action, so you guys have a really clear view about what we're trying to do here. We want to help you be able to really pick a great user scenario that you can build as a skill, something that you can actually put together. You can get feedback. You can go about improving that. That'll be something Hisami and Andy talk about. And then we'd love you to start building more to really get this moving. All the code samples you will see today will be available at the following link. Also, you can watch this. This session is being recorded. And then additionally, continue the education elsewhere with all the other great stuff going on this week. Additionally, there are some related sessions you guys might be interested in. I know there are a bunch that were yesterday. There's still more today and tomorrow that really look at skills, Cortana, and how we're bringing the platform forward. And then additionally, as you guys have heard, we're really excited to bring the Cortana Skill Kit, get it out there in people's hands, start using it. We have a lot of impact, a lot of user reach, and we'd love for you guys to help us make this ecosystem great. So I'm going to start by talking about designing voice user experience. And I thought I would start with a little video to sort of let folks know kind of how far we've come.
We should talk to Walter about the protocols.
Yeah, looks like I'm free this afternoon. Let's see if he has time. When can I meet with Walter this afternoon?
With whom do you want to meet this afternoon?
Walter.
Walter is available today at 1.
Confirm it.
Meeting with Walter scheduled today at 1.
Barry, why didn't it recognize your speech when we were talking?
Because it only listens when I talk in its direction.
Oh, I see. Does it bother you to wear that headphone all the time?
It's just like wearing a Walkman.
So the reason I show that's from 1985 from the MIT Media Lab. It's called Conversational Desktop by Dr. Barry Aarons. We've been dreaming of interacting with technology using our voice for a long time. But lucky for all of us, we're finally at an interesting inflection point where the technology and user expectations are beginning to actually meet, and we can start doing something that doesn't feel exactly like that. So I'm going to walk you through how we go about internally to Microsoft building and designing and selecting what becomes a Cortana skill, sort of one of her native skills. And then Hisami's going to talk with you guys about how you build a language understanding model, and Andy's going to really put it into action. So I want to follow that video with a great quote from Bill Buxton. So voice is great at everything it's not terrible at. Hope here today is that you walk out empowered to be able to get really great return on your effort by picking great experiences to do with your voice. I think we've all had painful, maybe terrible experiences we've tried with a voice interaction system. My time here is to try and help you guys pick really great things to go after, to build, to evolve, because these aren't just a one and done. These are things that grow, and they improve over time, and they tap into a lot of the machine learning and other services that we have. So, big question, when do I use my voice? What is it good for? So I think we've all discovered that it's great when I need another hand. It's really awesome when suddenly you can't reach out, or your hands are dirty, or you just need something else, and it's a great way to superpower what you can do. Sometimes it's easier and more natural. A lot of people can tell us what they want to do, they can tell us where they want to go, but they don't necessarily know how to get there. They don't know how to navigate, they don't know how to do those things. So voice is great at that. The next is it can be significantly more efficient. The number of clicks it takes to, say, launch into a movie player, find the movie you want, and actually watch it, it can be handled much faster when you can just traverse there with your voice. The next is about multitasking. Because we can actually have parallel channels, it allows for a user to stay focused on one thing and actually deliver an interaction in another place. Typing can be really cumbersome. We've tried this on a lot of devices, and particularly on devices that don't have screens or don't have other input mechanisms. This is your only way to go about it, but it really can be a great way to get over a bunch of use cases that would be complicated trying to do them another way. And the last is when you're distracted. I am not recommending that you guys do things while you're driving, but at the same time, it is actually a possibility to talk with someone else while you're doing something. You can also talk with an assistant like Cortana. So that can be very powerful, especially we've noticed when people are walking, when they're riding, when they're semi-distracted is how we try to talk about it. So if these are the times to use voice, when should I not use voice? This is really probably the most important part right now, is there's a lot of things that we choose to do with voice that are really terrible. And so hopefully this list will help us kind of move past that. If you expect someone to use this in a noisy environment, it's going to fail. Sort of the rule of all these demos is we try and not do live voice recognition because it really performs pretty poorly. So if you plan to do something in a bar, a restaurant, a subway, it probably is not going to function the way you expect. So maybe that's something just to avoid. The next is social settings. I don't know if anybody really wants to make comments about financial things or doctor's appointments, other stuff like that, in a room full of other people. I mean, maybe you don't care, but so far what we've learned is a lot of users have a lot of social anxiety about when and where to use their voice. So if you want a skill that's about being in public, make sure it's about public information, or it probably won't get used very much. The next is gradient controls. The idea that I want to say, a little louder, 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 that's not going to work very well. It's really great at jumping large contents of navigation, large sort of spanses, but skipping tracks, next, is really frustrating with your voice, and the number of steps it takes to get there just isn't efficient, so we should avoid it. And the last is really about content. I don't know how well you guys think that we can recognize things like passwords. I think all of us probably have some that don't just have regular words in them, or have capitals or special punctuation. So being able to get those right, creating content, a lot of long form things, there just isn't that much granular control. And so your voice isn't that great at helping deliver that. The next is at browsing content. Like I can get somewhere quickly, but navigating page over content is really pretty cumbersome with your voice. And the last is consuming things. I'm sure we've all had something start talking to us and we don't know how to turn it off. It just drones on and on and on and on. And so a lot of that is what we'll look at in the following slides. But if these are the things that you can do and that are great, and then there are these things that you can do that are pretty terrible, hopefully it can help us pick the right types of scenarios and the right types of use cases to go after for voice interaction. So I want to talk to you guys really quick about the core interactions that make up the entire voice story. So no matter what platform you work on, your voice does these three things. It will help you traverse. The idea that I can jump over lots of steps with my voice. I can say that I want to go to a named place. That's really awesome. Your voice is great at that. There are very few other tools or modalities that are really powerful in that way. The next is transformation, taking something that's in focus and in a sense getting an infinite right click. The idea that I don't have to wander through menus to figure out what I'm going to do with this thing, I just tell you. And then the last is capture. It's the one that gets forgotten the most, but it's the one we often use. The idea that just turn my voice into words, just capture them. And what's great as designers, what we do is we actually chain these together. The idea that I want to send a message to somebody is I'm going to traverse deeply into a new message for a contact. I'm going to capture what I say, that's the message. I'm then going to transform it because I can send it to somebody, I can add more, or I can start over. Those chained together are the things your voice does. The second you try and turn your voice into a mouse or something else, it is going to fail you, and you won't get great return on your effort. So something that might help as you think about building your skill and you think about the interaction and how you break it down, this is the model that we work through for all of our voice interactions. It really is the idea that starting at the left-hand side, a user forms awareness. They discover your skill, they understand and form the idea that they actually want to say something. The next is they get the system to listen. In our case, it's Hey Cortana. Can also be tapping on microphones or tapping other things that trigger that listening. The user's going to give us input. We're going to go through a stage of acknowledgement, letting them know that we hear them, and trying to let them know that we understand what they're saying. And that really brings us to sort of our red, yellow, green. It's a situation that from a system standpoint, either we got it right, there's a single response, there's a single answer, there's a single action, or we got close. And in that case, we're going to have to do something a little different, or we got it wrong. So the flow that everybody really wants to hit is the idea that, hey, I got invocation after awareness, I guide the user, they give input, we acknowledge that, we give them understanding, and we land at a single result. That's the goal. But in many cases, we actually end up in a place where we're close. And so in that case, we actually need to deliver the context back to the system and back to the service. So that thing I said, if I say it again, we actually are working to get closer to right. So we want to keep making the funnel tighter and tighter and tighter. And then the last is, we have to be really clear when we actually fail and deliver context of failure back into the system too. The idea that you told me that restaurant doesn't exist and I ask for it again, telling me it doesn't exist didn't actually solve my problem. So this kind of golden path that we have of getting to this single action, single answer is great from a system standpoint, but the thing we always have to remember is the user decides whether it achieved their goal or not. There are many times that we believe we are totally right from a systematic standpoint, and the user believes it is totally wrong. So that's a big part of the process that we're looking at and working through here. And so from this, there's kind of a set of rules that I would recommend that lead to successful design, development, execution, and deployment of a great skill or voice experience. And I kind of count them on my hand as 5. So the first one is we always have to design, plan, and actually develop against when we get it right. That's the path that almost everybody plans for, and it's magical. But in most cases, these systems actually, you spend more time dealing with the errors to lead someone with guardrails to the happy path or the successful outcome than you do on the actual adding a feature that will always be right. And so a big part of that is if you only bet on being right, you will ship a terrible skill. Because in the cases that you miss by a little, it will always come back as not working. And so really a lot of this is about how do you guide a user when you got close. And so in this case, we always plan, design, cost, and build for when we get it right. For when we get close, a big part of that is where we use disambiguation and guidance to help users get to the right place. The other is when we get it wrong. Admission of getting it wrong and not just erroring out is actually really key to bringing users back for another try. If they hit an error and they believe the error is on them, they likely will discontinue use of the product. So a big part of this is it may not be your skill, but if you can't help guide them to the right outcome, they may not engage with yours or other skills. The next is understanding that we got it wrong and something going wrong are things that for a long time we did not believe users understood. We very clearly understand now that users get that, hey, you don't know how to get me directions to this convention center versus I don't have network and therefore can't get you directions right now. And differentiating those in the messaging you deliver and the way you design this will actually help a user understand where it went wrong and how they can engage. And then kind of this concept of always having a backup plan really is key to figuring out how you can approach the problem with your users. And in the case that you solve for all these things, it will likely add up to a user believing that only the happy path, only that successful scenario that you showcase, they'll believe that that is all you shipped. But in the end, all of those other pieces guide them to that. It's sort of the toddler proofing the room to make sure all the sharp edges of our technology and our capabilities sort of don't lead to failure. The next layer I want to talk about is designing for clarity. So much of this is about actually writing words. A lot of this is about the things you say to folks and the things they hear. And so clarity is absolutely paramount through all of this, especially in cases where we don't have screens. So I wanted to talk to you guys about Cortana's dialogue. We think of her as an assistant. And really, the way we build all of those stories, all of those engagements, and all of the voice dialogues that we have is we start with the fundamentals of communication. I'll talk with those in a little bit, and the basic guidelines that we publish. And we layer on top of that adaptation to users, tasks, and the environment. So the more we know, is this user a first-time user? Have they been back again? Have they done something with this before? How do we actually tailor to the situation they're in? The next is the stage in relationship. Have they tried this before? How much guidance do I need to provide somebody who's trying my skill for the first time versus they're trying my skill for the 10th time or the 30th time? And then the last is a lot of the personality, branding, and style that's put on top of this. The thing that both reflects your skill, and for us, it reflects Cortana. And so really, by building in this order, it helps us deliver a great experience that isn't just about a parlor trick of a piece of personality or brand that you hope is really flashy. And so to that end, has anybody heard of Grice's maxims before? Nobody. Okay. So this is what we use, and a key to this is these are always in opposition to each other. The idea that being efficient, being relevant, being clear, and being trustworthy, if you go to the extreme of any one of them, they sort of cancel the others out. The idea that I can be incredibly efficient, and if I asked Cortana about the weather today, she could just say sunny. Well, actually, I guess today it's cloudy, but simply could answer with a single word. If it's Seattle, the answer would be rain. That's incredibly efficient. It is not clear and it is not trustworthy at all. So how do we find that balance of kind of always pulling, pushing and pulling on the dialogue we write to make sure that users understand what's going on? And to this, as you're writing for conversation, I don't know how many folks have written for conversations, but we all have conversations every day. And really the keys to great conversations are how we vary our output. If you give the same answer over and over and over again, you ask the exact same question the exact same way, things seem very, very rote. They don't feel flexible, they don't feel natural, they don't feel intelligent. The next is writing for the ear rather than the eye. I think one of the key things that we found, and it may sound a little weird, but we have listening parties where we actually listen. We don't look at screens. In some cases, we get in a car and we drive through traffic listening to either recordings or playbacks of these to figure out how much is needed. Like, what is the level of clarity that I need to communicate to a user exactly what's happening and how it's working. And then the last is that the language should really reflect what is going on in the interaction. So it could be what the user said, but additionally, it's about knowing, if I asked the user a question and they gave me an answer, we were testing a skill from another service this morning, and it asked for a particular form of transportation. And when you told it the form of transportation, it confirmed it with you. And if you said yes, it said, I don't know of a form of transportation called yes. In that case, you asked them a question and then you showed you weren't intelligent to the exact thing you asked them for. And then this is something that we're just starting to put out there, because something that is pretty unique for all of you guys is when you create a skill, it actually delivers to both screened and screenless experiences. And so a big part of this is there are a set of experiences for audio only and another that leverage screens. And so in the case that you have an audio only experience, it's really ephemeral. There's nothing persistent that hangs around. And so, hey, when you're there, the only interface you have to rely on is your voice. If you cannot complete a task with your voice, then you're kind of up a creek. The next is that each turn, just like a conversation, has to communicate somehow that it understands the context that it came from and offer you the opportunity for what you're supposed to deliver in return. Now, if it's the end of a conversation, that's fine. Could offer the start of a next conversation. But if you're midway through a conversation, you need to communicate what the next step is and where you are. Something we're always looking to do, particularly when it causes damage, the idea we're going to charge somebody's credit card, we're going to send a message out to somebody, we always want to make sure that when we get to the end, we're implicitly or explicitly, based on sort of how much damage can be done, confirming that with the user. It's letting them know, hey, this is what's happened. So if it's playing a song, cool, I'll play that song on this service and it's done. The idea that I'm about to, buy a car, I should probably ask, are you sure you want to buy that? And get that explicit confirmation from user. And the next is, don't be afraid to redirect a user to a screen. If you can't do it, it's better to tell them you can't do it than to pretend you can do it and fail, or just error out. And then, the last is sometimes it's just worth admitting defeat. There are some things that can't be done, and it's better to state that. For a long time, Cortana couldn't do email on Windows Phone 8.1. And we found that a lot of users were asking us to do email. It was better for us to tell them that we're still learning how to send email than to just send them to a web search or just fire an error that we didn't understand what they were saying. And the last, what's cool about leveraging a screen is it's persistent. And so what's great there is, just like a presentation, the audio and the video should, or the visual channel and the audio channel, they should be complementary, but they shouldn't overwrite each other. They shouldn't be one for one. We tend to be more clear and explicit through our audio channel and less explicit through our screen. But if you're looking at a big long list of things, you can actually cut through interfaces or experiences really quickly by being able to confirm things, tap on list items without reading lots of stuff. And then on top of that, we've learned that a lot of users work with their devices and their voice at a distance. And so asking them to sort of redirect their attention is actually a perfectly fine approach to really getting a great engagement. And so with that, I'm going to actually pass the mic to Hisami to talk about how we factor humans onto all of this.
Okay, so I am going to talk about language understanding. So Shane just talked about when to use voice, when voices are suited for making tasks easier for your users to do your task, do your skill. Language understanding is all about allowing users to speak naturally. So this is the kind of case, right? Shane was talking about you were sitting in the couch with a drink in your hand, and you are thinking about the upcoming trip to Seattle and want to find some hotels, let's say. There's so many different ways of asking for this information. Yeah? You may be able to say, find the hotels in Seattle, what are the good hotels in Seattle. So again, language understanding is to try to allow users to speak naturally. More concretely, language understanding reduces the variability in user input, what user says, into a limited set of labels. So let's start with a simple example like find a hotel in a city. So here's an utterance, find me a motel in Seattle. Your skill can handle it. First, you want to identify what user is looking for. In this case, the intent is find hotel. User intent is typically, there's one for the user utterance. You also want to understand a few important entities for your skill. In this case, you want to understand a specific hotel type, that it's a motel as opposed to a different fancy upscale hotels, and also which city the user is looking for the hotel. So these set of intents and entities define language understanding schema. And defining this is really central to creating a robust language understanding for your skill. So as you can see, all these variabilities, right, 4 different ways of saying the same thing, basically is reduced to this language understanding schema, 1 intent and 2 entities. And one thing you want to be mindful about is that as you collect more user utterances, you may find that it is required to update your language understanding schema because a new utterance presents something that you weren't thinking in the beginning. So this example in yellow, user says, find me a hotel near LAX. And you didn't really think through and didn't have the entity for the airport. Now you have to add it. You might think this is not a big deal, but if this keeps happening, it is really, really expensive, especially if you're having somebody else help you in labeling your data. So a good practice is to try to think about or ask people and try to gather as many relevant utterances as possible for your skills upfront, because this investment is going to pay later, really. Another thing are the negative examples. These are the kind of things that Shane was talking about when user is not hitting right in the middle of the target, right? Because this is a voice-only experience that you are building for your skill. There's no drop-down menu for the users to choose from. So the users don't really know exactly what's covered by your skill and what's not covered. So in this pink ones, like Seattle hotel deals, right? User is asking for specific deals. You don't want to just return any hotel search, right? But this utterance is kind of close to looking for hotels, so your skill may trigger. In order to prevent these things, you need to be mindful also that the schema covers the things you don't cover, right? So make a different intent, such as other or can handle. And for the entities also similarly, if you can't handle certain entities, like in this case, looking for hotel for a specific date, if your skill cannot handle it, it's still a good idea to have it in your schema so that you can tell the user, like, sorry, I can't look for hotels for a specific date, but here are some hotel suggestions or something. This will build trust with your users. Another thing, Shane talked about guiding the users to task completion. Even for a simple skill like hotel search, this could happen. So user said, help me find a hotel, right? And didn't say any city. So you want to prompt the user to give you the information you need. Which hotel are you, which city are you looking for, right? Then user says Portland. Now, this is sort of the getting close case in Shane's, right? This requires disambiguation because Portland is ambiguous. So your skill wants to say Portland, Oregon, or Portland, Maine. Then user says Oregon. Now, in this turn, you want to make sure that this Oregon is not overriding on Portland, right? This is Portland, Oregon. This is not like Oregon, Ohio. It's not a different city. So your language understanding has to be contextual in this case. Now, for the third turn, in response to your skill disambiguating like Portland, Oregon, or Portland, Maine, user may say the first one, right, to refer to Portland, Oregon. You need to have language understanding schema covering this as well, because this is very likely that user is going to say this, right? So you might probably need a different intent such as select and the entity for the position like the first or second. So even a pretty simple task like find hotel, the language understanding for the entire task can be fairly complicated. I want to quickly talk about how you evaluate your skill, especially in terms of language understanding. So like I said, make sure the simple skill, like the hotel, find hotel, with 2 entities, is covered well by language understanding before moving to support something more complex as a skill. So specifically, you want to look at, can the users actually be able to trigger your skill naturally using the everyday language? Can users successfully complete the task throughout? And also, do users really like your skill? That's really important, but the last one might need a user study. The first 2 can be covered by doing evaluation against language understanding that you are building. And in that context, it's really helpful to distinguish 2 types of errors. One is called precision error, and the other one is called recall errors. It's a pretty simple concept, but it's very, very helpful. So as you try to evaluate your skill in language understanding, you first need to have some labeled data, right? So the data of user utterances in sequence that's labeled with correct language understanding schema. And the actual user logs are the best. You can start with something that you collected yourself. Now, the precision errors are the types of errors that are over-triggering or over-labeling. So an example of this in intent is that, like I said, find hotel deals in Seattle. This isn't really find hotels, this is deals. But if you trigger your find hotel experience, that's over-triggering your skill. Similarly, in entity labeling, if a user says find nice hotels in Seattle, and this is unlikely in voice, but well, if it's transcribed, nice is the same as Nice in France, right? So you might tag this as city if you're just doing a lexical match. That would be over-triggering as well. The recall errors are the opposite type of errors where you are under-triggering, right? User says bed and breakfast in Portland, and this utterance doesn't have any word hotel, therefore you might under-trigger, meaning you miss this utterance. Also in entities, find hotels in Nice, somehow if you didn't tag Nice as a city, you have under-triggered, right? So these 2, precision and recall, are typically in trade-off relations. So if you try to increase recall, try to cover more of user utterances, typically your precision goes down. But in many cases, precision errors are typically perceived worse than recall errors, and these are the feedback we constantly get, right? So if you're over-triggering on something you're not triggering, gives users worse impression than you missed some of the utterances. You didn't trigger on some of the things that they said that are relevant. So the good practice here is to start with something that's high precision, and then try to work your models, collect more utterances and try to improve your recall. That's typically the recommended way. Okay, so now I'm going to give it to Andy. He's going to put all of these in practice and show a sample of how you do this in the tools for Cortana.
Thanks, Hisami. Okay, so how many of you have built a Cortana skill already? We've been live like 24 hours. We've already got a few hands going up. That's awesome. Okay, great. How many of you built a bot? I expect there's a few more hands will go up. Yeah, okay, cool. Right, so what I'm going to do now is kind of put into a real example encapsulating some of the great messages that Shane and Hisami have shared with you. And I'm going to keep it simple, just to kind of, so we don't get lost in the weeds. The samples, these are the bot builder samples. Some of you will be familiar with them. So we build Cortana skills with the Bot Framework SDK. There's a whole bunch of samples on here, and actually one of them on here, the roller skill there in the middle, which actually went up 2 hours ago, is a fully Cortana skill-enabled bot. So it has all the speech stuff in it. So it's a brand new update to the SDK that enables all of this sort of thing. I'm not going to show you that one. In fact, I'm going to look at 2 very briefly. So if any of you have looked at these samples, there's a kind of a bit of a theme running through a lot of them, which is this kind of hotel searcher scenario. And there's a couple of examples of that one. First of all, there's one there called the core multi-dialogue sample. Now, I've got that actually loaded up in Visual Studio here, the multi-dialogues bot. I'm just going to run it locally on my machine so we can see kind of how it works. There we are, it's running locally, and I'm using the bot framework channel emulator. I'm going to just connect to that local, to the bot, which is, which one are we on? Hang on, which port are we on? 3979, that one. So I'm going to connect to my bot. There we are, we got a conversation update. So I want to say, okay, search for hotels in Seattle. And there we go, it's accepted. Right, okay, immediately we've got a bit of a fail here. We told it we want hotels already, and it says, are you looking for a flight or a hotel? It's like, I just told you that. Like, so now this is an example. The reason this is happening, if we look at the code, it becomes very clear why that is happening. Not that one, I want to get rid of this guy. Okay, so if we look at the code down in here, stop it running. Now, for those of you who haven't done bots before, they are just REST web services, okay? So they have endpoints and you send messages to it. The thing about bots is they tend to be text messages. And the bot responds to it and it sends back a response. That's kind of all it is. So we've got this message received async method here. So let's see, we'll go up so we can have a look at this a bit better, which is where all the messages come into this bot. And you can see that we get the message as it comes in, and we have a look at the text, and then we're looking for specific words. If there's help or support or problem in there, then we go off to something called a support dialogue. So dialogue are these kind of subclasses that handle an interaction, a dialogue with the end user. But if it doesn't match one of them, we go off to this show options, which is just down here. And that puts up a prompt dialogue.choice, and the choices are flights option and hotels options. That's what you're seeing. So there's not much smarts in there, there's not much intelligence. This is what we call a guided conversation. Now, this isn't bad, because actually a guided conversation like this, you are leading in your bots very directly to specific outcomes. But you can get this kind of thing where the user says something, I just told you that, and the bot isn't smart enough to know about that. So there's a new version of this, which we'll have a look at now, which is another one that's in the bot builder samples. It's actually called Intelligence-Lewis. And instead of this kind of hard-coded dialogue stuff, it's got a Lewis model behind it. This is it. It kind of does the same thing. Let's just have a look, just to prove it actually works. Here's my bots. I'm going to go off in here. And we can test my bot, this one, straight away in the portal. And here I can go search for hotels in Seattle. And this time, because it's got Lewis behind it, it's able to do some language understanding on processing on that, natural language processing, and we've actually got some results back. So straight away, we've got a better solution. The user has gotten straight in and got the answer that they wanted. Let's have a look at the code. Oh, actually, of course, this sample is, of course, Cortana enabled. So let's hear what that sounds like. Ask Hotel Finder to search for hotels in Seattle.
Welcome to the Hotels Finder. Searching for hotels in Seattle. I found 5 hotels. Showing them for you now.
So a couple of interesting things there. First of all, it's nice, snappy, and concise. And we actually, on this particular device, we're making use of the fact we've got some display. We've got a little display. So the speech doesn't have to kind of slavishly speak out everything in this scenario. But let's have a look at the way this is actually built. So this is the main dialogue for this particular sample. You see the key thing here is, in the other sample, I'll just actually very briefly switch back to the other one. This is a dialogue, the root dialogue. It just inherits from this it implements this interface called iDialogue. So that's kind of a dumb dialogue. This is a smart dialogue. This is a Lewis dialogue. And so we are actually tying this particular dialogue up with a Lewis model, which has got this app ID, and this is an endpoint key. So we are tying this directly to a Lewis model, and we'll go off and have a look at that Lewis model in just a moment. And inside this dialogue, there's a whole bunch of methods which are marked with a Lewis intent attribute. So this method will fire when the Lewis model, so the user's utterance comes into the bot, it's sent off to Lewis for processing, and Lewis will send back to the bot service here, okay, I think the user said this, and these are the entities, so there's Seattle in there, and I recognize that to be a geographic city, and so, or it might come back and say, actually, the intent for this user based on my model was none. I don't recognize anything they've said here. They could have asked for peel me an avocado or something, which has nothing to do with the domain for this particular skill. So this one would fire, and of course then you're going to give back a nice message. Sorry, I did not understand. Then, of course, the key one here, search hotels, the Lewis intent. So if we get the search hotels intent firing, then we're off down into here. And this is just a very quick little primer for how you get a bot to speak in a speech-enabled channel like Cortana. Bots always make messages, that's standard, but then a couple of things to call out here. First of all, text is these two properties here. These are nothing to do with what is said. This is what is shown on the screen, if there's a screen. And one of the things that one of the messages we've got from developing Cortana skills is that you want to try and get what is shown on the screen to be obviously from the skill. And the way that you do that is you kind of highlight it, you give it a bigger font and italics. And the way you do that actually simply is on a response message, you just use the summary property, and that will come out bigger. The styling is fixed for you in the Cortana canvas. And if you want to follow up with any additional text underneath, then you can use the text thing. Speak is what she actually says, but the interesting thing to call out here is that don't slavishly, and these guys called this out, don't slavishly speak out exactly what is on the screen. In fact, if you do that, it's downright annoying for the end user. So here we've got welcome to the hotels finder, and we're also showing on the screen we're analyzing your message, but she actually just says welcome to the hotels finder. And we're using some SSML there. I'll come back to that in just a little while. So yeah, so we've got other methods in here for us, all of these other things like show hotels reviews. We've got one for help, of course, and we've got one for goodbye. So lots of different intents in there, and the bot will handle all of those just nicely. Okay, so this is a Lewis model. Here's the Lewis portal. These are my apps. The one we're using, this is one called Lewis Bot. So we'll just load that up so we can have a quick look at it. You will not be surprised to see that the intents are, of course, the same ones that were in those Lewis intent attributes in the app. So we've got the search hotels intent, and we've got a bunch of utterances in here. So here we've got a lot of different phrases that the user can say. So immediately we've got that support for natural language queries. It doesn't just have to be a very fixed phrase with a specific word in it. We can actually support lots of different ways for users to ask. Find hotels near something, show hotels, look for a hotel. And they're all slightly different ways of the user asking essentially the same intent, the same question of your skill. So when we create a Lewis model, we put in as many utterances as we can that match the intent, and then Lewis will build this machine learning backed thing in the cloud, which is super smart and intelligent, and it combines what you have said here, combined with its knowledge of how language is structured and the common usage, and it will come up with a model that will be able to not only identify exactly these phrases, but also ones that are quite close to it. So it learns over time and gets better. So we've got lots of cool stuff in there. All right, so that's kind of the first thing to call out about this. Let's ask her another question. Okay. Ask Hotel Finder to locate lodging in Portland.
Sorry, I did not understand. Locate lodging in Portland. Said help if you need assistance.
So there we go. So at least the skill has said, sorry, I don't get that, and it's being nice and polite to that sort of thing. But well, maybe we want to support locate lodging in Portland. Maybe it's a kind of a weird thing to say, but maybe we'll just make our skill even more user-friendly, and maybe it's the latest street slang or something, and we want to be able to support these kind of queries. Well, Lewis gives you a lot of help with these kind of things. So let's have a look at one of these intents. I think that would have come back as the help intent, I think. So one thing you'll notice up here, the utterances are the ones that have actually been entered into here, the obvious ones. But also there's suggested utterances in here. Now these were supposed to give you a list of things that is actually said, but this portal is sometimes a bit random on what it shows. Let me go and find off another one. Suggested utterances. Okay. So, right, when I went through this morning, this portal is preview as well. So what you should see here, I don't quite understand why they're not there at the moment. Oh, actually, I can see why I'm not there. I'm on a different version. Just a minute. Let me go back to, I need to go to settings and switch to different version of it. This is the one I want to use. I want to set that to be the active version, version 01. Okay, let's try that again. There we go. Off into the help, suggested utterances. Right, here we go. So these are all the things that have actually been said, mainly by me, because it's my skill, in testing, that didn't exactly match what were in the utterances already, but we can kind of add these in to improve the model. So, you know, this one, search for hotels, yeah, that's definitely, we can say, yeah, that's definitely a search hotels one, and it tells you what it kind of thinks for all of these. And help, yes, that's actually obviously a help one. It's kind of weird that's not in the list. And now we can go through all of these, and then we can save, and that's good. Let's go and have a look. I was expecting to find another one in there, so sometimes you have to go hunting for these sort of things. Let's go and have a look in help. No, not that one. So, must be none then. Let's have a look. Here we go. Here's locate lodging in Portland. That's what I said earlier. Now you can see it's been actually matched as a none intent. So I'm going to actually select this one, and I'm going to actually say no. That's actually, I'm going to reassign that to be, that's a search hotels intent. Sure, yes, I want to reassign that. And so that's been reassigned and saved. So now we can go off and retrain our model with that new knowledge, and we can publish it. Training doesn't take too long. All right, and then we can publish it up again to the cloud. And now I can sort of say, ask Hotel Finder to locate lodging in Seattle.
Welcome to the Hotels Finder. Searching for hotels in Seattle.
So all of a
I
sudden,
found 5 hotels.
all of a sudden we've extended our
Showing them
model.
for you now.
Yeah, thank you. Right, that's enough. So there you go. Immediately we've extended and learned, and you can kind of continue to tune your model and look at how people are using it, and so to get it to be more accurate and more responsive and give the kind of expected response. So that's really cool. Okay, so now then, that's the next thing I want to just talk about. So you will have noticed in there was some stuff about airport codes. So we also wanted, in earlier versions of this application, if you try to use, you could search for hotels in Seattle or Portland or Sacramento or whatever, and that would work. But what if you said, oh, search for hotels near LAX? So everybody knows that means Los Angeles International Airport. But in the first versions of this particular sample, it would just treat that as Lax or something, try and find a city called Lax. And so that was a precision error, an example of it kind of thought it knew what you meant, but the skill hasn't identified correctly what the intent would be. So another nice thing we can do in Lewis is we can create another entity. So we've extended this to actually understand and support airport codes. So the way we've done that is we've added an entity. So the entities are the things that are getting pulled out of utterances. And we've actually got one called airport code. There it is. And we can have a look at the labeled utterances for airport code. And we've got some utterances in our model that actually use this airport code. Now, how does it distinguish from an airport code from a kind of geographical location? Well, there's also this features thing in here, which is really nice, which you can use to improve the understanding of your model. First of all, this one you're seeing here is phraseless features, which are essentially synonyms. So what this is saying is that near, around, close, and nearby are all kind of the same as near. So that's one thing it does. And show, find, look, search are kind of synonyms for that. But the other one here is pattern features. This is where we can specify a regular expression for an entity. So we've got an airport code regex here that says it is 3 A to Z characters. So this is, and obviously an airport code. So that has now, that knowledge has been built into our model as well. So now I can go onto here, ask Hotel Finder to search hotels near SFO.
Welcome to the Hotels Finder. Searching for hotels in SFO. I found 5 hotels.
Not sure that worked, actually. I was supposed to say SFO Airport, but okay. I want to look at, for me, in this one. But also, I wanted to show you something else as well, related to this. Ask Hotel Finder, what can I say?
Hi. Try asking me things like, search for hotels in Seattle, search for hotels near LAX Airport, or show me the reviews of the Bot Resort.
So a couple of things there. First of all, we've got good support for the user who comes and needs to know what your skill can do, because especially if it's a voice-driven experience, you know, they need to be able to, you need to have help built in. But the other, oh yeah, thank you. So clearly, I didn't know what to do with that. All the hidden problems with voice stuff. But the other thing about it, you'll notice that she knew how to pronounce LAX. It was a bit labored. I could probably tune this a little bit more, but it did say, you know, you can say, search for hotels near LAX Airport and that sort of thing. So that's pretty cool. Now, the way that we can do that, help a great user, a voice user experience, is by tuning responses. So the very first version of this, I had that message. Let's go have a look at the code for this, which is the help one. Down here, here we go. This is the help one. And of course, the first speak was basically the same as the summary there. So it would say, hi, try asking me things like search for hotels in Seattle, search for hotels near LAX Airport. And you're going, no, that's not what I meant. So we can use SSML, speech synthesis markup language, yes. Whatever, I forgot what the second S is. And you can actually kind of start to influence how she pronounces stuff. So here we've got SSML has an opening, is an XML, so it has an opening speak tag, and of course it has a closing speak tag, and inside it you have the text that should be spoken. So we have, hi, try asking me things like search for hotels in Seattle, and search for hotels near. Now this is very interesting. So I did a bit of tuning here. I've got a little class here, SMS helper say as. Let's have a quick peek at what that looks like. And obviously this just does some XML stuff. It formats a say as element with an interpret as attribute, which is how in SSML you can ask it to pronounce something in a particular way, and there are interpret as numbers, as digits, as characters, as currency. There's a whole bunch of them in the SSML standard. So that's embedded in there. And of course, you can put little break times in as well. So when I first did this, it would say, search for hotels near LAX Airport. And it didn't sound natural. So that's why I put a nice little 200 millisecond break in there. So actually, when you build a voice-enabled app like this, tuning the naturalness and the sound of how things are pronounced back is quite an important part of the work you need to do to make sure that it sounds as natural as possible. The other thing that Hisami called out was also, and Shane, was that you shouldn't be repetitive. So this one actually, there's still some work to do on this. It's a little bit, it always says, welcome to Hotels Founder, and I think maybe we should probably drop that after they've used it a few times. Or you can change some of the wording a little bit just to help it sound a bit more natural. But so changing the phrasing and use of SSML is all good things for making a skill sound more natural. Okay, so the other thing that we have in here is a bit of guided query stuff. So if we ask for something incomplete, Ask Hotel Finder to search for a hotel.
Welcome to the Hotels Finder.
Yeah.
Please enter your destination.
Okay, so it's prompted for missing information, so that's a bit of guided conversation that's built into this as well. There's some interesting technical points in the bot about this, but I'll leave you to read the comments on that, because I want to move on and give you still some time for a bit of questions. But I want to say also, what about voice? We've seen how this skill works, and it puts some stuff up as cards. What if this was running on an Invoke speaker that doesn't have a screen? Okay? Now, I haven't got an Invoke speaker here, as you can see, but we can actually get this skill to behave as if it has no screen. So in the logic for down here, we have some, when we get the results back, oh, here we go. So in a bot, you get, with your incoming activity, you get a bunch of entities. And if it comes from Cortana, then one of the entities you get is this device info. And it will tell you whether the device that's calling you has a screen or not. So obviously the Invoke speaker will say, no, I don't. So we use that information to actually give a customized response. So here I've got two ways of presenting the results. First of all, with those visual cards, which is what you've been seeing. And I'm just going to copy that out, comment that out, and then republish. So we can see the experience, well, we can hear the experience. It will still display on the screen, of course, but you need to just close your eyes and go with me on this one, okay? So we're publishing up to the cloud. Publishing up to the cloud. Still publishing up to the cloud. There we go, getting there. Right, we're good. Okay. Ask Hotel Finder.
Sorry about that.
Oh.
I didn't hear anything.
Maybe double-clicked something. Ask Hotel Finder to search for hotels in Seattle. I think the internet slowed down. Based on that pause out.
Welcome
There
to
we
the
go.
Hotels Finder. Searching for hotels in Seattle.
So ignore what you're
Here
seeing.
are the first three results. 1. Splendid Hotel, from $141. 2. High Class Hotel, from $177. 3. Excellent Hotel, from $252. Which one do you want to hear more about?
Last one. And, okay, it's, that one's not responding. So I was about to tell you about the wonders of the prompt dialogue, which has been imbued with great voice support. It's been released, obviously, this week. There's a few rough edges in it. I have seen a few glitches like that. The sample that's up on GitHub has the prompt dialogue. It's really good for speech because it allows you to, it has built into it the ability to select by number, 1, 2, 3, or the first one, last but one, so it understands ordinals. It's got great voice support in. It's not quite bug-free, as you can see. So we're still, we've just released this, and that one didn't work so well in this particular example. But normally it would come back and say, oh yeah, I found it. Now the point about that is we gave them a shorter list by voice, so you need to tailor the responses for a non-screen position. You don't want them to listen to loads and loads of information. By the time they get to number 5, they've kind of forgotten what it is that the beginning of the list was. So with that, we've got a few minutes left. I'm about done with this, so sure. Yeah, we'll actually switch over and give you an opportunity to ask us some questions before we finish. If you wouldn't mind, could you go to the microphone? And we get it on the recording.
So in our line of business, we have specialized entities. How difficult is it to get Lewis to identify those and recognize them as particular entity types?
Do you want to answer? Yeah, I think there's a lexicon feature.
Sorry?
There's a lexicon feature in Lewis. So I guess I believe in Lewis, so I'm not a specialist on Lewis. There should be, I think there is a feature to include your lexicon into Lewis. Now, having speech recognition, recognize those is another, difficulty. I think something that needs to be done. And I'm sorry, I can't really speak about the tools. There was somebody talking about this topic yesterday. Maybe we can chat afterwards and try to find the right contact to answer this question.
I want to show you there is this. When you create your entities, you can create a list where you can match against specific things. We can also use the regex feature that I showed you to kind of match a pattern for a particular entity. And then building into the model, in this list you can have up to 20,000, I think, different entries in this list. So that becomes like a phrase list. So you should be able to match up in your Lewis model to the domain of your entities that you're looking for.
Sure, come on up to the mic.
What resources would you recommend us to go to look for multi-turn or conversational help? So if we wanted to build something that was more of a conversation.
So the bot builder samples that I showed you actually have multi-turn examples in. We will be publishing ones specifically around Cortana. The only multi-turn bit in there was like if she prompted you for, where she was prompting you for things. But essentially, when you're talking to Cortana skill, it is turn-based, so it is kind of request-response. But the good thing about Cortana skill is your skill can send back a response and say, hey, say this, but you can also set a flag on it called an input hint to say, oh, and by the way, I'm going to follow up with another message. So you effectively get this kind of asynchronous messaging kind of model as far as your skill is concerned. But with input hint, you can actually, let's see, you can control the microphone. Here we go. Input hint here. Response for input hint is you're saying, ignoring input says, I'm going to follow up with another message. But another option is accepting input, which means the user can say something, can turn the mic on. Expecting input, the Cortana will automatically turn the mic on. And ignoring input is the one I've shown there, which it says ignore anything they say. So you have good control from your skill as to how you are interacting with the user, and you can continue to prompt them for more information when you need it. I briefly showed that with the asking for the destination when it was missing. But absolutely, you can build these things. Bot Builder samples have demonstrations of how to do multi-turn.
Two questions. One, are there plans to add some kind of built-in lists of entities, like, for example, the ones that exist in Amazon Lex or API.ai, like, say, list of the cities in the US or countries and so on? So that's number one.
Yep, there you go. So these are all being built-in entities for age, date, time, extractor, dimension, email. This is encyclopedia. Money and number, and that actual skill I showed you there is using geography, so it can pick out cities and the geographical things. So there's a list there, and we are continuously enhancing these and adding additional ones to it. So that is absolutely, yes, definitely a part of the model for this.
Are they language specific? I mean, they have to be. Probably.
Yes, they do. So we expand them out over different regions as soon as we can. But that's the Bing team developed these entities.
But for now, it's English only.
For now, it is.
Okay.
Yes.
So question number two: does it make sense maybe to add some kind of markup-based design instead of going through all these hoops in the code and defining all these things manually?
You mean the code for the conversation and everything?
Yes, that's right. Yeah, because it's kind of, sometimes it looks like a boilerplate code.
Yes. Yeah. So one of the other, you'll have to come back to me, because there was another session at Build where we previewed a conversational designer where you can use a GUI to kind of define these interactions, which still builds a Lewis model underneath, but in a more graphical, more sort of drag and drop kind of way, and with decision points and modeling a dialogue in that way. So we are working on that kind of thing.
But it generates code, not markup. I mean, like procedural code.
It generates, well, it's traditional Microsoft tooling, if you like. So there is some JSON, some XML there that defines the interaction between elements, and then you have code behind to actually make decision points and the like. So.
Thank you.
Thanks.
Yeah. Hi, I have a question around the speech modeling. So I noticed you added 200 milliseconds between LAX and airport because it sounded a bit sort of strained otherwise. Presumably, as the Microsoft speech models improve, it will add a pause there, from the model itself. So how should developers, add these manual pauses, paired with the model updating?
So I defined that just through trial and error. I think, that didn't sound so great. So unfortunately, it's one of those, you have to kind of get to know the text-to-speech engine that is generating the audio that you're hearing. And within our system, it's the Bing one. So you can at least be confident that you'll get to know its foibles and its characteristics over time. But does that answer your question?
Yeah, I guess my question was more around, so as the Bing model improves and adds these pauses more naturally, how should one think about improvements in the model versus manual edits?
Manual edits. Yeah, no, you're right. I mean, obviously, we're working on it all the time to make the built-in capabilities much more natural. And over time, you might find that pause you put in your V1 all of a sudden is making things sound unnatural by the time you get a bit further down the road. And all this stuff, it's unfortunately the price for developing and supporting a skill, I'm afraid.
Thanks.
Do we have time for one more? Yeah.
Hi, good afternoon. Dinesh Kithani, industry analyst from iJust Market. A question, good stuff here. Question is, how are we integrating the skill sets which are used for voice assistant technology with the face recognitions or image recognitions here? Because I guess today or tomorrow, Evoke will have the face recognitions capabilities as well, I guess.
Yeah, so Cortana Skills Kit uses Lewis.ai for natural language understanding, and over time there will be, it's part of the family. You can today, with a Cortana skill, you can use a bot as purely as a mechanism for silently launching an app on Windows and Android systems, and that app could then use any of the Cognitive Services API for turning on the camera and doing facial recognition, and can do its own voice interactions. So that's the kind of, you can use the bot as basically as a voice-controlled trigger for something else that has a bit more smart capabilities. In time, I guess we'll look at seeing how we can incorporate some more of the cognitive services directly into access from the bot framework for a bot running through Cortana. So, there are bot samples already for bots using speaker recognition and that sort of thing, but it depends on the channel whether the audio gets passed through. So it's not a sort of a story that is the same across all of the different channels. But certainly, we can launch into an app and do all the kind of cool, interesting stuff with all of the services that you mentioned there right today.
Thank you, everyone. We'll be at the AI booth this afternoon if you guys have questions.
Thanks very much.
Thank you.